Welcome to this beginner's guide to mineral identification. Today, we'll be discussing the basic properties and characteristics of minerals and how to use them to identify different types of minerals. Mineral identification is an important skill that can be useful for anyone interested in geology or mineralogy, and with practice, it can be a fascinating and rewarding hobby. Understanding the physical properties of minerals is an essential skill for any geologist, rock hound, or mineral enthusiast. The physical properties of minerals include color, streak, luster, hardness, cleavage and fracture, and specific gravity. Color is often the first characteristic we notice when examining a mineral, but it can be unreliable for identification since many minerals come in different colors. Streak, which is the color of a mineral's powdered form, can be a more reliable indicator of mineral identity. Luster refers to the way a mineral reflects light, and can be metallic or non-metallic. Hardness is another important characteristic, and can be tested using the Mohs scale, which ranges from 1, softest, to 10, hardest. Cleavage and fracture describe how a mineral breaks along planes of weakness, and specific gravity refers to the density of a mineral relative to the density of water. Understanding these properties can help us identify different types of minerals, and we'll be discussing specific examples of common minerals and their identification characteristics in the next section. So, if you're interested in learning how to identify minerals, stick around for the rest of the video. In this video, we'll be discussing the physical properties of minerals and how they can be used to identify different types of minerals. Understanding the physical properties of minerals is an essential skill for any geologist, rock hound, or mineral enthusiast. The physical properties of minerals include color, streak, luster, hardness, cleavage and fracture, and specific gravity. Color is often the first characteristic we notice when examining a mineral, but it can be unreliable for identification since many minerals come in different colors. Streak, which is the color of a mineral's powdered form, can be a more reliable indicator of mineral identity. Luster refers to the way a mineral reflects light, and can be metallic or non-metallic. Hardness is another important characteristic, and can be tested using the Mohs scale, which ranges from 1, softest, to 10, hardest. Cleavage and fracture describe how a mineral breaks along planes of weakness, and specific gravity refers to the density of a mineral relative to the density of water. Understanding these properties can help us identify different types of minerals, and we'll be discussing specific examples of common minerals and their identification characteristics in the next section. So, if you're interested in learning how to identify minerals, stick around for the rest of the video. In this section, we'll be discussing some of the most common minerals and their identification characteristics. By understanding the physical properties we discussed earlier, we can use them to help identify different types of minerals. First, we have quartz, which is one of the most abundant minerals in the Earth's crust. It is typically clear or white, and has a hardness of 7 on the Mohs scale. Next, we have feldspar, which is also quite common and can be found in a variety of colors such as white, pink, and brown. It typically has a hardness of 6 on the Mohs scale. Mica is another common mineral, which can be identified by its thin, flat, and flexible sheets. It typically comes in shades of brown, black, or white and has a hardness of 2.5 to 3 on the Mohs scale. Calcite, on the other hand, is a mineral that is often found in sedimentary rocks and can be identified by its white or clear color and its tendency to effervesce or fizz when it comes into contact with acid. Finally, we have halite, which is also known as rock salt. It has a characteristic salty taste and is often colorless or white in appearance. Its hardness is only 2.5 on the Mohs scale, which means it can be easily scratched with a fingernail. Of course, there are many other common minerals out there, each with their own unique identification characteristics. By familiarizing ourselves with these characteristics and using the proper techniques, we can become proficient in identifying a wide range of minerals. Of course, there are many other common minerals out there, each with their own unique identification characteristics. By familiarizing ourselves with these characteristics and using the proper techniques, we can become proficient in identifying a wide range of minerals. In this section, we'll go over some practical tips that will help you with mineral identification. The first tip is to use proper lighting and observation techniques. This means observing the mineral in different angles and lighting conditions to see how it reflects light and appears under different lighting conditions. The second tip is to use a hand lens or magnifying glass to get a closer look at the mineral. This will help you see the details of the mineral's structure and texture, which can be important for identifying it. The third tip is to know the geologic context of the mineral. This means understanding where the mineral is typically found and what types of rocks and minerals are usually associated with it. This information can help you narrow down your identification options and make a more informed guess. Finally, the fourth tip is to practice and repetition. Like any skill, mineral identification takes practice to master. Keep trying to identify different minerals and keep studying their properties and characteristics, and eventually, you'll become an expert at mineral identification. Welcome to the final section of this beginner's guide to mineral identification. In the previous sections, we covered the basic properties and characteristics of minerals and how to use them to identify different types of minerals. But what if you come across a mineral that doesn't fit neatly into one of these categories? Or what if you need to identify a mineral that's very similar to another mineral, but has some subtle differences? This is where advanced mineral identification techniques come in. These are more specialized and nuanced methods that can help you identify minerals that might otherwise be difficult to distinguish. Here are a few examples. X-ray diffraction. This technique involves shining X-rays on a mineral sample and analyzing the pattern of diffraction that results. This can give you detailed information about the mineral's crystal structure and composition. Infrared spectroscopy. Infrared spectroscopy measures the way that a mineral absorbs and reflects different wavelengths of infrared light. This can help you identify specific chemical bonds within the mineral, which can be used to identify the mineral itself. Electron microscopy. Electron microscopy involves using a high-powered microscope to look at the mineral's surface at a very high resolution. This can reveal details about the mineral's texture, shape, and composition that might not be visible to the naked eye. Of course, these advanced techniques require specialized equipment and expertise, and may not be accessible to everyone. But if you're serious about mineral identification, or if you're working in a field where accurate mineral identification is critical, these techniques can be invaluable tools to have in your toolkit. And with that, we've come to the end of our beginner's guide to mineral identification. I hope you found this video informative and helpful, and that it's inspired you to explore the fascinating world of mineralogy further. Remember, mineral identification is a skill that takes practice and patience, but it's also a skill that can be endlessly rewarding. In conclusion, mineral identification is an essential skill for anyone interested in geology or earth sciences. By understanding the basic properties and characteristics of minerals, we can identify different types of minerals and their uses. We have covered the physical properties of minerals, including color, streak, luster, hardness, cleavage, fracture, and specific gravity, as well as mineral identification tests such as the acid test, magnetism test, and fluorescence test. We have also discussed common minerals and their identification characteristics, such as quartz, feldspar, mica, calcite, halite, and others. Finally, we have provided tips for mineral identification, including proper lighting and observation techniques, the use of a hand lens or magnifying glass, and knowing the geologic context of the mineral. Remember that like any skill, mineral identification takes practice and repetition to master. I hope this beginner's guide has provided you with a solid foundation to continue your journey in mineral identification.